Here's a quote from Albert Einstein. "Nothing happens until something moves." What do you think Einstein meant by this? In this video, we're going to discuss what inertia is, the effects it has, and what affects it. Inertia is the resistance to a change in motion. So an object at rest remains at rest, and an object in motion remains in motion with the same velocity, unless acted upon by an unbalanced force. Inertia is why you feel a jerk as the brakes are applied in a car or a bus. Your body tries to continue moving forward, but your seatbelt, which is attached to the slowing car, applies the force that also slows you down. Inertia is the resistance to the change in velocity. We can demonstrate inertia using the following experiment. You will need a glass or a cup of water, a coin, and a piece of card. When the card is pulled, the coin falls into the glass. This is because the inertia of the coin maintains its state at rest, and as long as the friction between the card and the coin is not too high, it falls into the glass due to gravity. It's also why the plates stay in place when the magician pulls the tablecloth away. The inertia of an object depends on its mass. More mass means more inertia. A greater resultant force will be needed to change the motion of an object with a high inertia. For example, which of these trolleys will require a greater force to start or stop it moving, or indeed to change its direction of motion? That's right, the trolley with the greater mass will require the greater force. A similar thing happens if you're in a car turning a sharp corner. It seems like you're flung outwards, but actually it's your inertia which resists the change of direction. The car moves in this direction. This is where you would be if no force acted. You carry on at the same speed and direction. Friction between the car tyres and the road applies a force that enables the car to change direction. You were pushed round by the car, but it felt like you were being flung outwards. Inertial mass is a measure of how difficult it is to change the velocity of an object. The larger the inertial mass, the bigger the force needed, or the smaller the acceleration produced by a given force. Force equals mass times acceleration. For example, it would require a much larger force to throw a shot put at the same speed as a tennis ball. This is because the shot put has a much larger inertial mass. So is inertia useful in any way? We can use inertia in mechanical devices such as inertial reel seatbelts in cars, and in seismometers that detect and record earthquakes. This is a simple device, which contains a suspended mass connected to a sensor. Simple paper and pen is shown here. When there is a tremor, in one horizontal plane, in this example, the entire case and the attached paper will move to and fro. But the large mass, due to its inertia, will not. So the pen will move over the paper, leaving a trace that records both the severity of the tremor and its duration. So what did Einstein mean when he said nothing happens until something moves? He was talking about inertia.